Hello and welcome to another Ginger Mathematician video. So today I'm going to go through all of iGCSE Surds, and this is for the 2025 course for 0580. So if you're taking iGCSE 0580 in 2025, then this is new content you need to be aware of, specifically E1.18 on Surds. If you do the 0607 course, again this remains, so you need to be aware of this topic as well. Done a little bit of practice on 0607 questions. Again, you can check that out in my all of iGCSE maths playlist. Now, for 0580, what has been added? Well, we need to understand and use surds, which we'll go through today, including simplifying. So I've given some examples here. And we also need to be able to rationalize a denominator. I'll also talk about that in this video. So what are surds? So what actually are they? All they are is they're square roots of non-square numbers. So for example, the square root of 5, that is a surd. Whereas the square root of 4, which is equal to 2, that is not a surd. So we're focusing on numbers that don't work nicely. Now, the first skill that we need to know here is simplifying surds, and we're going to use this fact here in blue, which is if you have the square root of a times b, that's the same as the square root of a times the square root of b. This really helps you to simplify your surds. So let's do a few examples of this. So notice here we've got the square root of 4 times 5. I can use this rule directly here to split this into the square root of 4 times the square root of 5. Why do we do this? Well, this means then we can work out the square root of 4, which is equal to 2. Remember, something times something gives you 4. What is that something? That's 2. And then we can just write the root 5 next to it. Remember, with algebra, 2 root 5 means the same as 2 times root 5. Now, sometimes it's a bit trickier. We have to work out how to split the number here. So we have 28. The key thing to remember, we want to split it into two numbers where one number is a square number. Now, what are our square numbers? Well, we have 1 times 1, which is 1. 2 times 2 is 4. 3 times 3 is 9. 16, 25, 36. 49 and so on. So when I do these kind of questions, I have a list of these either written down or in my mind, so I can think about what two numbers multiply to give me 28, one of these numbers coming from this list. So in this case here, we can split this into 4 times 7. Notice 4 is in my list. If I tried 2 times 14, neither number is in my list, therefore that's not going to work. As soon as I've got this, I can now split this in the same way I did before. So I have the square root of 4 times the square root of 7, and now I can simplify in exactly the same way. The square root of 4 is equal to 2, root 7 we leave alone. So this is the first key skill you need to do, be able to simplify your surds. If we take our next example here, the square root of 45, I want two numbers that multiply to give me 45. One number comes from my list. Notice 15 and 3 is not in my list, but 9 and 5 is, or at least the 9 is in my list. Then we can split this into the square root of 9 times the square root of 5. The square root of 9, something times something gives you 9. What is the something? That's going to be 3. And then we write the 5 next to it, like so. Now, we'll go through a few questions here. Again, this is the way to really practice these skills. Okay, let's look at some of these questions and do the same skill. So I'm going to go through A first of all. So I want two numbers that multiply to give me 8, one of which comes from my list. Here we have 4 times 2. We split this across, so we get square root of 4 times the square root of 2. We can then change the nice number, the square root of 4, to 2, and leave the root 2 alone to give us 2 root 2. Let's do question D as well here. So the square root of 75, two numbers that multiply to give me 75. one of which are off from my list. Notice I might have to go as far here as 25. So we've got 25 times 3. This is a really important step. Then we split this. So we have the square root of 25, the square root of 3, the square root of 25. So something times something gives me 25. What's that something, which is the same? That's 5. And then we put the root 3 next to it to get my answer right there. If you want more practice on this, again, have a go at some of the questions here in the box. Again, I'll put the answers here for you as well, so you can check through everything that we've done so far. Now, one of the reasons that we do this is going to help us with some addition later on. A key rule to remember here, I'll do a couple of these questions with you, is that if you are multiplying by the same number, so if you're doing root 2 times root 2, then that just gives you the original number. So root 2 times root 2 just equals 2 on its own. Root 5 times root 5, that will then give you just 5. If the numbers are different, so we have root 2 times root 18, all we do, we work backwards to what we did before. We do 2 times 18, so we can put it under the square root. 2 times 18 is root 36. And don't stop at this point, because we can actually simplify this. Something times something gives me 36. What's the something? That's equal to 6. Now notice sometimes we might have to simplify. So here root 6 times root 3 is equal to root 18. You might think you're finished at this point, but remember the previous slide, which is we can split this, if sometimes it's possible, into 9 times 2. Then we get the square root of 9 times the square root of 2, and that simplifies to 3 root 2. So always check if you get a square root of something, see if it can be simplified. And again, use that list of 1, 4, 9, 16, 25, 36. See if those numbers go in. And you can have a practice here at your leisure. Okay, so the reason we do simplifying, it allows us to add and subtract surds. So we can't do square root of 48 plus root 27. We can't just add them together and get the square root of 73. That doesn't work because the functions are both non-linear. So the reason we simplify, it allows us to make this a single surd term. Okay, let's talk about what that actually means. So first of all, we need to split both of these square roots with a square number. Remember our list of square numbers: 1, 4, 9, 16, 25, 36, 49, and then we continue. Notice 48 here is an interesting number because 4 goes into it, 4 times 12. However, the bigger the number, the less work we have to do later. So the key thing to notice here is actually we have a bigger number that fits in, specifically 16 times 3. 27 here, we can use the idea of 9 times 3. We've seen that same idea before. And the reason that we've done this, we've now split this with a square number. So we have then the root of 16 times the root of 3 plus the root of 9 times the root of 3. Now the reason we've done that, we know what the square root of 16 is. That's equal to 4. So we get 4 root 3. We know what the square root of 9 is. That's equal to 3. And then we get this calculation here. 4 root 3 plus 3 root 3. Now think of it like algebra at this point. Notice if I did 4a plus 3a, that's equal to 7a. We approach this now in exactly the same way. 4 root 3 plus 3 root 3 is equal to 7 root 3, which is our final answer here. So there's a few different things going on. We're building on what we've done in the previous slide. Subtraction works in exactly the same way. So again, the first thing we want to do is split each of these into two specific numbers. Now notice we could actually start with the smaller number here, so 54. Notice that can be split into 9 times 6. You really need to know your times table as well here. Now I'm going to use a kind of trick here that I didn't mention in the previous question. Notice both times here we had a 3. So I'm pretty sure we're going to have a 6 here. And then what do we multiply by 6 to get 150? Well, in fact, it's one of our square numbers, which is 25. So if they give you a question like this in a non-calculator exam, which can happen in 2025, it has to be something that simplifies. Notice I've been sneaky here. I've used this 6 here to work out this must be 25 times 6. Once we've done that, we can do some nice simplifying, like so. Again, we'll make sure we're going to minus later on. That gives us then root 25 is equal to 5 root 6. Root 9 is 3 minus 3 root 6. Again, we think of it now like 5a minus 3a, which is equal to 2a. So that gives us then 2 root 6 as our final answer there. You can use the same ideas that we've talked about before to do our next question here as well. So we're thinking, okay, how do we even simplify these really big numbers? Usually not so big on an iGCSE paper. Let's start with the smaller number here. So notice this can be written as 25 times 5. Okay, 25 being one of our square numbers. So we know actually one of these numbers needs to be 5. What do we do to 5 to get to 245? Again, we can do some simple division at this point, which you do need to know for the course. So then we get 4, carry the 4, and we get 9. Aha, we actually get a square number here, 49. So notice I didn't need to know 49 times 5 here. I can use this calculation, the easier one, to help me with the harder one. Again, we simplify at this point. Root 49 is 7, so we get 7 root 5 plus 5 root 5, giving us 12 root 5. Okay, if you find this really valuable at this point, then please do like the video. That's the most important thing to do. If you want to know anything more about iGCSE Maths, subscribe so you can see all these videos. If you want a challenge, have a go at root 8 plus root 50 and do it in exactly the same way. Okay, now even though this is not mentioned specifically on the scheme of learning, it is useful to know actually we can use surds with brackets as well. So I'm going to do a brief example of what goes on here. Remember our FOIL method for expanding brackets, generally speaking, with double brackets, first, outside, inside, last. We follow exactly the same order using the maths we've already done. So 1 times 2 is equal to 2. Then we have the outside. 1 times root 3 is just root 3. 2 times root 3 is where some students get confused. If we're just multiplying a number by a surd, we just keep it the same, 2 root 3. And then we have root 3 times root 3. Now we've seen this already. If we have a root 3 times itself, we just get the number itself. So we just get 3. And at this point, we collect the like terms. So we have a 2 here. We have a 3 here. 2 plus 3 is 5. And notice we have a 1 root 3. We don't usually write the 1. 1 root 3 plus 2 root 3. That gives us then 3 root 3 for our answer. Whenever you're multiplying out brackets like this, most of the time you'll get a number of some kind and a surd next to each other. Be absolutely happy with that. That's absolutely fine. What I'd like to look at is something a little bit more tricky here. So let's look at question C. Again, we still use first, outside, inside, last. So 3 times 1 is 3. 3 times minus 3 root 2. So let's think about that for a moment. Whenever we multiply numbers with surds, focus on the numbers first. 3 times minus 3 is minus 9, leaving the surd alone. 1 times root 2 is just root 2. And this is where it can get a little bit tricky. We have root 2 times minus 3 root 2. So again, let's have a little think about this. First of all, we use the rule that we looked at before. So root 2 times root 2, that gives me 2. We've still got a minus 3, so we've got 2 times minus 3. 2 times minus 3 is equal to minus 6. So again, just like before, we still get a number in our last term here. Now we simplify, so we have a 3 here, a minus 6 here. That gives us minus 3. And now we have minus 9 root 2 plus 1 root 2. Again, you can think about that as minus 9a plus 1a. That gives us minus 8a. Therefore, it works in exactly the same way, minus 8 root 2 as our final answer. Strictly speaking, not in that scheme of learning, but it's a very useful skill to know anyway, and we're still testing the same ideas as well. Again, if you want a question to have a go at, and let me know in the comments how you get on, have a go at this one. That'd be interesting to see what answer you get there. Now we're on to the last part here, which is rationalizing the denominator for these particular surd expressions. We'll start with some easier ones and then we'll do some more difficult. What does this mean? So denominator, that's just the bottom of the fraction. So know these words. And rationalize, all that means is make the bottom, or to rationalize it, make it a non-surd, i.e. a fraction, a whole number essentially. Usually it's a whole number here. So how do we do this? How do we actually do this trick? Well, notice if I multiplied this by 1 over 1, i.e. 1, it doesn't actually change what the fraction is. If I multiplied this by, say, 3 over 3, also doesn't change what this fraction is because 3 over 3 is just 1. So as long as I have the same thing top and bottom, it doesn't change what the fraction is. What I'm going to do here is multiply by root 2 over root 2. Notice, doesn't change what the fraction is. Root 2 times root 2, or root 2 divided by root 2 is equal to 1. Now we just multiply fractions in the normal way. 1 times root 2 is root 2. Remember our rule from before, root 2 times root 2 is equal to 2. Notice we've achieved what we wanted to do from the question. The bottom of the fraction is a non-surd, it's a whole number. Now, b works in exactly the same way. All we do is take our fraction and multiply this time by root 3 divided by root 3. Then we just use normal fractions. 5 times root 3 is 5 root 3. Root 3 times root 3 is just 3. And we're done. Next question. Now we do it by root 5 over root 5. That gives us 10 root 5. Root 5 times root 5 is equal to 5. But there's an extra step with part C. You knew there's a trick somewhere. We can also simplify our fractions. Notice we have a whole number 10 and a whole number 5. So how many 5s go into 5? 1 time. How many times does 5 go into 10? 2 times. So just watch out for your simplifying fractions. This actually simplifies further to give you 2 root 5. If you want some practice, again, you can have a go at some of the questions over here. Now, where it gets a bit trickier is when we have in the denominator a surd and a number together. This is where we have to be a bit more careful using the skill we just saw about a couple of slides ago. So notice, if you multiply by root 2 top and bottom, we won't actually clear out the entire surd from the bottom. So we do need another strategy. Our strategy is to multiply by its conjugate. Now you're thinking, what's a conjugate? I've never heard of this word before. It's a fairly straightforward idea. All we're going to do, top and bottom, is multiply by root 2 minus 1, top and bottom. You're thinking, why is that actually going to achieve what we want to achieve? Well, let's go through it and see what happens. First of all, we have a single bracket here on the top, so we multiply this by this, and this by this. 5 times root 2 is 5 root 2. 5 times minus 1 is minus 5. Okay, all good. The bottom is a double bracket like we saw a few slides ago. So we use our first, outside, inside, last. Let's have a look at this question then. So root 2 times root 2 is just 2. Root 2 times minus 1 is minus root 2. Plus 1 times root 2 is plus root 2. And 1 times minus 1, please don't ever put 2 in the exam, it is equal to negative 1. Now it feels like we've actually made this more complicated than it should be. But notice we get a minus root 2 and a plus 2 root 2 cancelling. So we end up with 5 root 2 minus 5 over 2 minus 1, which is just 1. And notice we actually achieve what we wanted to do. We get a 1 at the bottom of our fraction. By multiplying by a conjugate, we get the thing that we're looking for. We make the bottom a whole number or a fraction. This question works in exactly the same way. Now notice we took negative because we have positive here. Here we do it the other way round. So we multiply by root 7 plus 2, top and bottom, working in exactly the same way. If you want to think of it like brackets, that helps you with the multiplying, by all means please do. 2 times root 7, that gives us 2 root 7. And then 2 times 2 is equal to 4. And then on the bottom here, again we use our first, outside, inside, last. Root 7 times root 7 is 7. Root 7 times plus 2 is 2 root 7. Minus 2 times root 7 is minus 2 root 7. Notice these cross terms are always going to cancel. And then minus 2 times plus 2 is equal to minus 4. Careful with negative numbers. Notice we get this great cancellation, leaving us with just 7 minus 4 on the bottom, which is equal to 3, a whole number, that's what we wanted. And then we get 2 root 7 plus 4, and that is our final answer. Again, they don't really get much more difficult than this on the iGCSE course. Okay, so now let's look at some specimen paper questions. So these have been specially prepared by Cambridge to get you used to the 2025 course. So first question here, we need to simplify this addition. We've seen a question just like this already. So the key thing to do here is we need to simplify these surds. Let's start with the smaller number, so root 32. Notice we can write that as root 16 times 2. So the biggest number that fits in, which is a square number. Again, I can use that to help me with this number because I know there needs to be a times 2. So I need to think, okay, if I divide 98 by 2, get 4, carry the 1, 2s into 18 go 9. Aha, another square number, in this case 49. Again, use the first part to help you with the second part. Then we simplify this, so root 16 is equal to 4, so we get 4 root 2. Square root of 49 is equal to 7, so we get 7 root 2, 4 root 2 plus 7 root 2, that gives us 11 root 2. Again, think of this like 4a plus 7a is equal to 11a. So we get 11 root 2 for our 2 marks. Here we've seen a very similar example already, earlier part in the video. So we have 1 over root 2 plus 1. We need to multiply by its conjugate. Again, what does that mean? We multiply by root 2 minus 1, top and bottom here. Again, you can always think of this like brackets. If we multiply the top, well, 1 times root 2 minus 1, that's just going to remain as root 2 minus 1. Multiplying by 1 doesn't change what it is. Now we use first, outside, inside, last. So root 2 times root 2 is 2. Root 2 times minus 1 is minus root 2. 1 times root 2 is plus root 2. And then 1 times minus 1, careful, is equal to minus 1. We get this nice simplification in the middle, leaving us with root 2 minus 1 over 2 minus 1, that's 1, which we could just then write as root 2 minus 1 to give us all 2 marks on this question. Then you can see the mark scheme. You get a method mark for knowing about conjugates, and then 1 for the answer. If you put root 2 minus 1 over 1, that would probably get the 2 marks as well. And notice 11 root 2 for 19a. On to our second question here. Almost identical, but this time we have a negative instead. Still approach it in exactly the same way. Notice root 3 can't really be simplified here, but we can simplify the root 75. Notice we already have a 3 here, so I'm thinking to myself, what do I multiply 3 by to get to 75? Aha, a square number, 25. So we can simplify the first surd here. Root 25 is equal to 5, so we get 5 root 3 minus root 3. Just be careful at this point. This is the same as doing 5a minus a, which would then give us 4a. So 5 root 3 minus 1 root 3 essentially is equal to 4 root 3. One of the biggest mistakes that's made on this kind of question is you forget to subtract and you add instead and put 6 root 3. Please don't do that in the exam. The next part, again, we approach this in the same way as before. So we have 8 over 1 minus root 5. We multiply by its conjugate, so it's positive version here. So 1 plus root 5. Even though the surd and the number are the other way round, still approach it in the same way. So let's work our way through this. The top here is a single bracket, so 8 times 1 is 8. 8 times root 5 is 8 root 5. And then we do the bottom with first, outside, inside, last. So 1 times 1 is 1. 1 times plus root 5 is plus root 5. Minus root 5 times 1 is minus root 5. And then be careful here, minus root 5 times plus root 5. That gives us negative 5. So be careful with that. Then if we continue, we get 8 plus 8 root 5. We have the cancellation in the middle. That gives us then 1 minus 5 is minus 4. And we're not finished at this point. You have to look out for cancellation here. Notice 4 goes into this number, and this number. If that's the case, you have to simplify through. So how many 4s go into 4? 1 time. How many 4s go into 8? 2 times. How many 4s go into 8? 2 times. So we get 2 plus 2 root 5 over minus 1. Notice that looks a little bit ugly here. So what we can do is then just put the minus through. So we get minus 2 root 5. And that will be our final answer for a fairly tricky 3 marks here. Again, you can look at the mark scheme here. Notice you could also factorize this as well and put it back in. That's absolutely fine as well. Again, both answers will give you all 3 marks. And again, we've got 4 root 3. Notice correct answer only. Again, if you don't get 4 root 3, then you won't get all 2 marks here. If you want some more practice on surds, then I do suggest you check out the video right in front of you. Even though this is more for the 0607 course, it's very, very good practice for 0580 as well. So if you're not sure about some of the concepts we've gone through in this particular video, do use that video to catch up on them.